Hello everyone, welcome to the Electron Flow Academy. So today we are going to solve the numerical problem number 2 based on the previous topic transformers, self-induced EMF and mutual-induced EMF. Okay, the question is given to us is that the self-induced inductance of a coil of 500 turns is 0.2 Henry. Okay, and if the 60% of the flux of the coil is linked with the second coil of 10,000 turns, then calculate the mutual inductance of the two coils. Okay, of the two coils and EMF induced in a coil when the current in first coil changes at the rate of the 100 ampere per second. Okay, so let's start the solution. So firstly, the given parameters are N1 is equal to 500 primary number of turns, N2 secondary number of turns is given as 10,000. Okay, and L1 is equal to 0.25. Okay, this is given to us. Next parameter is given as that di by dt, which is equal to 100 ampere per second. Okay, this is given to us. Rate of change of current. Okay, so here firstly we noticed that mutual flux okay, so phi 2 is equal to 60% of phi 1. Okay, so this condition is given us in the question here. 60% of the flux of the coil is linked with the second coil. Okay, so we can rewrite this equation like phi 2 is equal to 0.6 times of phi 1. Okay, so this is the ratio is given to us. Okay, so next thing is that here now mutual inductance between the two coils is equal to given by M is equal to N2 phi 2 divided by I1. Okay, so here we can rewrite like N2 into we can rewrite the phi 2 is equal to 0.6 time of the phi 1. Okay, 0.6 phi 1 divided by I1. Okay, so we can calculate the mutual inductance from this expression. So let's put the value like M is equal to now N2 is 10,000 into 0.6 phi 1 divided by I1. Okay, or we can rewrite this M is equal to 6,000 phi 1 divided by I1. Okay, so this is our equation number 1. Okay, So next thing is that we know that L1 is equal to self-inductance of the primary winding is L1 is equal to N1 phi1 upon I1. Okay. So here we can write that phi1 upon I1 is equal to L1 upon N1. So we know that the value of the L1 and N1. Okay. L1 is given us is 0.25. Okay. This is given us in the question. Okay. So the value of L1 is here 0.25 Henry. Okay. It is not 0.2, it's 0.25. It's given us in the question. So let's put the value like 0.25 divided by 500 number of the primary turns. Okay. So the value of this ratio is equal to 0.0005. Okay. So this is the value of this ratio. Now let's substitute value of ratio which we have calculated phi1 upon I1 in equation 1. Okay. What we are doing here, this value phi1 upon I1, sorry, this is I1. We are putting this ratio here. Okay, in the equation number 1. So let's see now M is equal to 6000 multiplied by 0.0005. So that the value of the mutual inductance is equal to 3 Henry. Okay. So this is our first answer, the mutual inductance of the coils. Okay. Next thing is that asked in the question is induced EMF in second coil. Okay. This is the asked in the question in the second coil. When the first coil current changes at the rate of 100 ampere per second. Okay. That means the induced EMF of the secondary coil is given by E2 is equal to, we know that this formula M di1 divided by dt. Okay. So we know the value of the M which is equal to the 3 Henry and di1 by dt is given to us in the question which is equal to 100 ampere. Okay. We write down this in the given section. Okay. 100 ampere. So simply now E2 is equal to 3 multiplied by 100. Okay. So E2 is equal to 300 volts. Okay. So this is our second answer which is asked in the question. So this is the induced EMF in the second coil. Okay. So this is how we have solved this numerical problem based on the transformers self-induced EMF and the mutual induced EMF. Okay. So thank you very much. Please like and subscribe our channel.